Welcome back. I'm back with another interesting topic today. So, we have discussed almost half of Verilog. So, today I thought of doing something different. So, in today's class, we will be discussing about most frequently asked questions in Verilog. Okay, like these are most frequently asked in interviews as well as in when you are joining for any internships, and if you want to attend any written tests on Verilog. Okay, so these are most frequently asked questions. Okay, so let us discuss all these questions today. Okay, so don't miss this out. And before getting into the topic, if you are new to my channel, consider subscribing my channel and hit on the notification bell also, so that you will be notified as soon as I upload the video. And also follow me on LinkedIn, where I'll be uploading all these PowerPoint presentations there. Okay, also follow me on Quora also, where I'll be answering your questions. Which one of the following is not a data type in Verilog? So I have given you four options, like either it is rich, integer, float, or real. So rich, integer, and real, these all are the data types that you have seen in Verilog. But float is the data type which is not in Verilog. Okay, for real numbers we'll be using real data type, not float. Okay, so this is the answer of this particular question. And then in Verilog, how do you specify the size of rich data type? So in order to specify the size of rich, any data type, not only rich, in order to specify the size of that particular data type, how you will be notating it? By using n down to 0 notation. That means, for example, if you are taking like some rich A, okay, so this is my particular variable. So in order to notate this size, what I'll be doing, if you see this is of 1 bit size. Okay, if I want to increase the size of this, what can I do? Reach some 4 down to 0 A. Now what happens? This size of A has increased from 1 bit to 5 bits. Is it or not? So any data type, not only rich, either if you use like integer, okay, but like integer and real, they'll be having the default data type even though you don't mention the size. But for rich and wire, since their default size is 1 bit, so if you want to increase the size, you have to give the size like in this notation. So this is the correct answer. Then which operator is used for bitwise? Okay, so today I have uploaded these in the LinkedIn. So while answering, most of them have answered that this is the bitwise operator. But no, this is not the bitwise operator, this is the bitwise AND. Okay, if you see this is the logical. Okay, this is logical AND and this is bitwise AND. Okay, so here this is bitwise. Okay, this is logical and here this similar thing you will also have one more with single end, one more operator which is having single end. What is that? Reduction end. Okay, reduction end is also single, whereas bitwise AND is also single. But how will you see the difference between bitwise AND and reduction AND? Reduction AND will be having only one operand. Okay, bitwise AND will be having two operands. That means when you are using reduction AND, you will be using only one operand. But when coming to bitwise AND, you will be using two operands. Okay, when you are using a single AND symbol between two operands, then you can remember that it is a bitwise operator. And when you are using it with one operand, then you can specify it as a reduction AND. Okay, so this is the logical AND. Clear, right? So this is, can we have multiple always and initial blocks in module? Yes, if you don't listen to the class of like initial, what is initial and what is always block, okay, I'll link that in the description box, so you can go check it out there. But we can use multiple always and initial blocks in a module. That means when you are writing like module and end module, okay, this is your particular code, then you can use the initial or always block any number of times you can use it. like any number of times you can use it, but the only condition is that if you are using the initial block, it will be executed only once. And when coming to always block, it can be executed multiple times. And also, there is one thing that is not to be done here. What is that? Either in initial or always, nested initial or nested always blocks are not valid. This is the thing that you should remember. Any number of always blocks you can use, but you cannot use initial within initial. That means you can't write initial block within another initial block. First you should end that first initial block and then you should start the second initial block. Okay, that is the thing. So the answer for this is yes. And initial block can execute multiple times. No, it's a big no. Why? Because initial block is only executed once. Okay, when it comes to always block, it can execute multiple times. Okay, next, assign keyword is used for continuous assignment. Okay, what is this? Assign is the keyword here. Okay, I think you know about this assign keyword. I will also link the data flow modeling explanation. You can check that there. Like assign is the keyword, okay, which is used in continuous assignments. So the answer is yes. What is the purpose of RTL design verification? So what is the purpose of your verification? To simulate and verify. Okay, in order to simulate and verify the code, you are using this RTL design verification. Okay, so this is another interesting question, and this is the question most of you have commented it in a wrong way. Okay, so you also remember this, because these are the questions which may seem easy but they are tricky. If you don't concentrate on that particular thing properly, these questions are, they may seem easy but they are really tricky. Okay, so check this out. Here I have taken A as this value and B as this value. Okay, now I am giving the operator 3 equal to, if you see this, what is this operator? Firstly, this is case equality. Okay, if you are using 3 equal to symbols, then that is case equality. If you are using only 2 symbols, then that is equality operator. Okay, now what is the difference between equality and case equality? In equality, if you are having any x or z values, it will return the output as x. Okay, but in case equality, even though there are x and z values also, it will compare x and z values also, and it will return only two values, only 0 or 1. So the output of case equality may be either 0 or 1. Okay, the output of case equality can never be x or z. Okay, it can be either 0 or 1. That's it. But in case of equality, it is not like that. In case of equality, the output can be either 0 or 1 or x. Okay, but not z, because z is also considered as x in equality. So either 1 or 0 or x. These are the three things when it comes to equality. But when it comes to case equality, only two options, either 1 or 0. So see here, this is case equality. So 1, 1. Fine. X, x, fine, x, x, fine, z and x. Now here comes the dispute. Okay, z and x, so not equal. So what is the output of this thing? Not equal means 0. Okay, got my point? Which operator has highest precedence in Verilog? Okay, most of those who commented me in the LinkedIn, they didn't answer this particular question. Okay, so what is the meaning of this? Means highest precedence means when you are executing something. Okay, for example, when you are writing a condition, the condition will be executed, is it or not? So that execution will be having some order. Okay, I'll give you some example for this. While you are small, you used to learn about BODMAS rules, is it or not? Like bracket of division, multiplication, addition and subtraction, BODMAS rule. So what is that rule actually? Depending upon the priority of the BODMAS rule, all the things will be they use like depending upon the priority of the operators, they use it to work it on it. Is it or not? Similarly, here also in Verilog, the depending upon the precedence, the execution will be done. So when coming to the highest precedence in Verilog, that is given to arithmetic operators. Okay, so arithmetic operators is having the highest precedence, and then relational, then equality, and so on. So in operators, the least precedence is for conditional operator. Okay, this is how the precedence is. Like it is, first precedence is given for arithmetic, and then relational, and then equality, and so on. Okay, and then again in arithmetic also, if you come for precedence, okay, in arithmetic the first precedence is for addition, and then for multiplication, and so on. So if you see here, among this, what is that? Addition is having the highest precedence. Okay, so next thing, in the given code snippet, so this is my code. If you see in this code, the statement 2 will executed at, that means at what time period the statement 2 is being executed. So if you see here, initial, okay, since I am having two statements, so begin and end, so within begin and end I am having two statements. Okay, x and y are the two variables. If you see here, at #5, x is executed at 1 tick be 0. That means at 0 time period, actually at 0 time units, the initial block will be starting to execute. But here at 0 time unit, there are no statements. But after that, at #5, that means after 0, after 5 time units of delay, the x value is 0. Okay, and then after 5, then after 15 time units, what is the value of y? It is given as 1. Now if you see the tricky part here, most of you think that it will be executed at a equal to 15, but that is not the case here. What did he ask? Statement 2 is executed at what time? That means from 0, okay, 0 plus 5 plus 15. So this is how the execution is done in, say, this is blocking assignment. Okay, so this is how this execution will be done here. How is it? Like 5 plus 15, that means the execution is given at 20 but not at 15. Okay, so this is the tricky part here. You should just check out the delays topic that I have uploaded it. Okay, you can go check it out. I'll also link that in the description box. So your next question is, which level of abstraction level is available in Verilog but not in VHDL? That means there is one level of abstraction in Verilog but it is not there in VHDL. What is that? That is switch level abstraction. Okay, if you see this, switch level is the abstraction which is there in Verilog but that is not there in VHDL. Okay, so if you see here, in Verilog, tick H1234 is A. What is this? If you see here, this is how you will be notating. Okay, how you will be representing some value. When you are representing the value, you should mention the size. But here you didn't mention the size. Even though you didn't mention the size, you have given the base, like which base it is. Either it is hexadecimal, decimal, octal, or else anything. So here you have represented it as a hexadecimal. So that is why the default value of hexadecimal is 32-bit. So that is why it is 32-bit hexadecimal number. Okay. So the possible values of equality operator are, in the previous slide I have told you, for equality operator you can have three possible values: 0, 1 and x. Z is also considered as x in equality operator. So 0, 1 and x. Okay, if net has no driver, it gets the value. It's nothing but he is asking the default value of net. Net is nothing but wire. Okay, so he is asking the default value of wire. So what is the default value of wire? It is Z. Okay, and then coming to default value of ridge. If you see here, and the opposite of wire is ridge. So this default value is X. Okay. So you can remember either one. Like if you remember reg as x, then you no need to remember y. Y is obviously z. So you try to remember either one of these two data types default value, because this data type default value is most frequently asked question. If anyone want to know how strong you are in your basics, mostly they will prefer these types of questions, because these types of questions may seem easy, but they are really hard and tricky to remember. So that is why try to remember it in a tricky manner. If you try to remember one thing like either ridge or wire, then the opposite of that one will be the second one. So you could try to remember it that way if you like. And then here if you see this thing, I have also asked previously also the same question, but here in the previous I have asked like a 3 equal to nothing but a case equality I have asked. But here I am asking equality. For equality, even though you find 1x, here I am having 3x's, not 3x's. Even though there is 1x also, you can blindly put the value as x. Okay, clear for equality. But for case equality means it doesn't have x, it is having only output as either 1 or 0. Okay, right? So if you see here, again one more program. Initial value of a equal to 1 and b equal to 2. Then what will be the final value? If always at the rate passage of clock a equal to b, always at the rate of passage of the clock b equal to a. Now he is asking that a equal to b and b equal to a. Now what will be the values? So according to you think that a equal to the first values are a equal to 1 and b equal to 2. So then what has he done? A equal to b, b equal to a. So many of you think that a will be equal to 2, b equal to 1, right? But this is not the case here. Okay, such type of toggling can't take place in case of this continuous, this blocking statements. Okay, these are called blocking statements, and such type of thing is not possible when it comes to blocking statements. So the answer is neither this nor this. Then what will be the answer? Both a and b will be having same value. That means either a and b will either be 1 or a comma b will be 2. Okay, so this is the answer. Both a and b will have same value, either 1 or 2. Okay, so why is this answer? You will know once you know about blocking and non-blocking statements. Okay, so once you know the difference between blocking and non-blocking statements, you will be getting this answer. I'll also be explaining about blocking and non-blocking statements in my further videos. Okay, so to subscribe to my channel to see all those videos further. Okay, and then so one more question. So this, if you see in the previous question, I have told you that if you see in the previous question we have given like x equal to 1 tick b 0. So that is why the execution of the second statement is done at 20 time units. But here less than or equal to, if you see here, this is not less than or equal to, this is called as non-blocking assignment. Okay, you'll also be knowing it in the further classes. So in case of non-blocking assignments, all the statements are executed parallelly. Okay, in case of blocking statements, that means if you are giving it like this, y equal to 1 tick b1, okay, then this execution will be done sequentially. That means after execution of one statement, then comes the second statement. But in case of non-blocking assignments, all the statements are executed parallelly without taking care of another thing. Like it doesn't, the execution of first statement doesn't have any consideration on the second statement. The execution of second statement doesn't care about the third statement. So that is how the working is done in case of non-blocking assignments. So from this you could get the answer. The output is 15, because every statement is executed parallelly without waiting for the before statement. So that is why the output here is 15. But in case of blocking assignment, the output is 20. Okay, so this is how. Variable and signal, which will be updated first. Obviously signal is the thing that will be updated first when during the execution is done. Okay, and then to suspend a simulation, you can use this system task. Okay, in order to suspend the simulation, suspend means nothing but in order to stop the simulation, you can talk it as like that. Okay, in order to stop the simulation, what you will be using? Dollar stop. Okay, in order to suspend, nothing but in order to stop the simulation, you will be using dollar stop. In order to terminate the simulation, that means in order to complete the simulation completely, in order to make your simulation come out of the particular thing, what you will be using? Dollar finish. Okay, there is a difference between termination and suspension. Okay, termination means it is ended there, you can talk it like that. Suspension means it is there is still code that to be executed, but it is stopped there. Okay, so that is the difference between termination and suspension, and that is the difference between dollar stop and dollar finish, right? In continuous assignment statement, LHS can be, okay, that means here any like, what is the meaning of this is assign LHS is equal to RHS. This is our statement. So in this, what should be your LHS? Obviously your LHS should be net. Okay, it can't be wire, but it can be either scalar or vector net. So nothing but concatenation of both or all of the above. Okay, you can call it like that. For today's vlog, so I'll be coming with much more interesting topics in the further classes, and also I'll be giving you all these interview questions in the further classes also. So if you like this video or if you like my explanation, do like, share and comment. And also if you're having any doubt on this particular topics, please comment me in the comment box, and also do follow me on LinkedIn, because I'll be uploading all these PPTs in the LinkedIn.